Alright, well, we're going to do a little bit of geometry here together today. Section 10.5 is more information about relationships between angle measures and arcs. And if you remember, I mentioned in the previous section that a big idea is where is the angle located. So be thinking about that as we go through today's lesson. Okay, where is the angle located? So remember, we're looking at three different types of T's this chapter: terms, theorems, and test questions. And there are no new terms. Just be very familiar with tangents, chords, and secants. I think we've talked about those enough times now. You should know them, but if you have to review your notes, please do so. Tangents, chords, and secants. So let's use these now in a number of theorems, all of which are pretty important, and I'm sure you will see on upcoming quizzes and tests. Theorem 1011. Theorem 1011 states, if a tangent and a chord meet on the circle, on is the important word or reminder here for you. Remember yesterday we talked about inscribed angles that are often found on the circle. So if a tangent and a chord meet on the circle, then the measure of the angle formed is 1/2 the measure of its intercepted arc. And remember, you can always pause this video, replay it, listen to it again if you need a little extra time with a particular idea. So take a little picture of this theorem here. Here's my circle. I'm going to draw a tangent to the circle and a chord within that circle, and you can see the angle formed up at the top. Hey, this looks a lot like an inscribed angle, and it is perfectly okay for you to treat it like an inscribed angle. So anytime that vertice or that vertex is on the circle, the angle is going to be 1/2 of its arc. Alright, so that's our first theorem. Again, very much like the inscribed angle that we looked at yesterday. Second theorem today, Theorem 1012. This says, if two chords intersect inside the circle. So that is your key phrase, key word for this theorem. Inside the circle, in the circle. Then the measure of the angle formed is 1/2 the sum. So remember what that would be. Sum is just a fancy math word for a plus problem, an addition problem. Okay, so it's 1/2 the sum of the measures of the intercepted arc and its vertical angles intercepted arc. That's a little bit confusing. So look at a picture of that. But we're talking about two arcs here. We're talking about the arc formed by the angle, and then the one directly across from that, its vertical angles arc. So in this picture here, you'll see that I draw two chords inside the circle, and there are 4 arcs in this problem. The one on the left, the one on the top, the one on the right, and the one on the bottom. So let's say that we are talking about this angle right here. Okay? It's inside the circle, but it isn't necessarily in the middle. Remember, if it's in the middle, we refer to that as a central angle. And remember, the central angle is always equal to whatever arc it's making. This is not right in the center. But let's say we want to find the measure of one of the angles on the left or the right. Alright, now we know vertical angles are always congruent. Okay, those two angles are always congruent. But what we're going to do is we're going to take the two arcs that are formed by those two angles, the one on the left and the right, and we are going to add them together. So 75 plus 45 equals 120, and 120 divided by 2 is 60. So each of those angles in there is 60 degrees. Okay, remember, vertical angles are always congruent. These angles don't equal the arcs on the outside because they're not right in the center. Okay, so add the two arcs together and divide by 2. And remember, you'll get practice with these here in just a few moments. Alright, our last of our theorems today, 1013. Remember, lots of theorems this chapter. Hopefully you're keeping tabs on everything and staying up on them. If a tangent and a secant, or two tangents, or two secants. So there's a couple different scenarios going on here. If any of those things are meeting outside the circle, so outside is the key again. We had one on the circle, we had one inside the circle, and now this is outside the circle. So if any of those things are meeting outside the circle, then the measure of the angle formed is 1/2 the difference. Remember, difference is a fancy math word for a subtraction problem. So we had an addition problem earlier. Now this will be a subtraction problem. So 1/2 the difference of the measures of the intercepted arcs. So whatever arcs are found in between the sides of the angle. So I'm going to show you a couple different pictures here because it can look differently depending on which of those things in the beginning we're talking about. So the first one we'll look at is if you got a tangent and a secant. So there's my tangent, there's my secant. Okay, you can see the angles formed there. Alright? So if I'm looking for that angle up there in the top left, I have to know what that arc is, that 120 degrees, and I have to know what that little arc is right in there, that 50 degrees. So to find that angle there, the theorem tells me to subtract those two arcs, the big one minus the small one, and then divide by 2. So 70 divided by 2 is 35. 35 degrees is the measure of that arc. Alright, what if I have two tangents now? Two tangents. Now, a picture like this, I might not give you a lot of information because there's only two arcs in the problem. There's the bottom arc and there's the big arc. And we know that the two arcs have to add up to 360. So I might only give you one piece of information in this problem, something like this. Because if you know that that arc is 110, then obviously the other arc is the leftover part out of 360. So the big arc is 250. And now what am I going to do? I'm going to take 250 and subtract the other arc, 110, and then divide by 2. So 140 divided by 2 is 70. And that is the measure of the angle down at the bottom. Last but not least, we've got our last picture, which would be two secants. Two secants. So I got two secants that are drawn here. You got a lot of arcs in this picture, but the only arcs you're really concerned about are the two that come in between the sides of the angle. Now it looks like I've indicated that one secant actually contains the center. So it's a diameter. So the first thing we're going to have to do is figure out what's that leftover little arc there. So we know that that is a diameter, so we know that there is 180 degrees in the semicircle on the right. And so we can do what to figure out that x? Well, we could take the 80 and the 60 and add them together, and that's 140. And so we know that the last piece of that semicircle must be 40 degrees. Now I have my two arcs. So I'm going to do what with them? Since it's outside, I always subtract the two arcs and divide by 2, and that's going to give me a 20-degree angle for my answer. Okay, so let's summarize all of this. I've given you a lot of information here in the last 10 minutes or so. Let's summarize. There are 3 places that angle could show up. It could be on the circle, in the circle, or outside the circle. Anytime that your angle is on the circle, what we are going to do is take the measure of the arc and divide by 2. That is our angle measure. I hope you're taking really good notes with this. This is a great way to summarize these 3 lengthy theorems. If I am inside the circle, I am taking the measure of the 2 arcs, the arc formed by the angle I'm looking for and its vertical angles arc. And what am I going to do with those 2 arcs? I am adding them and then dividing by 2. That will give me each of those angle measures, the angle and its vertical angle. And then lastly, anytime I'm outside the circle, so it could be different scenarios, remember, but anytime I'm outside, I am going to take the 2 arcs that fall in between the angle, and I am going to subtract those 2 arcs. And then divide by 2, and that is my angle measure. So we had our theorems. As always, let's wrap this up with a couple of test questions, potential test questions. So I'm going to give you 2 problems here to work on. Once you copy the problems down, or see that I've copied the problems down, push pause on the video and take a few minutes to work on the 2 problems. Once you've worked on it, then go ahead and hit play and resume the video and see if your solutions look like mine. So you got a pair of concentric circles in the first one, and you're trying to solve for x. The second question is very much like a potential test question. You are going to find all of the angles and all of the arcs in this picture. So like I said, this is very much like what my questions will look like on the upcoming quiz and test. So again, once you've had a chance to look through all these and work through the problems, resume the video and compare with my answers. I'll be back with you here in just a few moments. Alright, so let's see how you did. So for me, the first thing I see in this problem on the left is I have an angle that is on the outside circle. So I'm going to take the arc that it creates, the 124 degrees, and divide it by 2 to get that 62 degrees for my angle measure. Now that angle is outside of the inside circle, the inner circle. So I'm going to subtract those 2 arcs and divide by 2, and that gives me my angle. I'm going to cross multiply, take 62 times 2 to get 124, and now I'm going to solve it for x by subtracting 167 from each side, and then dividing both sides by a -1 to get 43 degrees for x. So 2 of the 3 theorems there, on the circle and outside the circle. In the second problem, I see the right angle there. So what that tells me is that this right here is a semicircle. Remember, we learned that yesterday. Anytime you have an inscribed angle that's a right angle, then it must be inscribing a semicircle. So since it's on the circle, I know that I've got 180 degrees. I know I have 120 up there, so subtract that to give me the 60-degree arcs down at the bottom. So I know all my arc measures right now. I know 180 and 60 and 60, and then the other angle up at the other arc at the top must be 120 as well. To find that angle right there, that is on the circle. So I'm taking my 60-degree arc at the bottom and dividing by 2. And the angle to the left of it is exactly the same. Since I have a 30-degree angle and a 90-degree angle in this triangle, I know my leftover angle must be 60, which matches up with what I said earlier, that the arc across from it has to be twice as much, 120. Now let's work on my angles on the outside of the triangle. That angle right there. Alright, that's outside, so I'm taking the two arcs that it creates. That one and that big one over there. And I'm going to subtract them. So 180 minus 60 divided by 2 is going to give me 60 degrees. So that angle there is 60 degrees, and the one in the other corner of the picture is 60 degrees. Again, I've got 90-degree angles in that triangle there, so that tells me that my last little angles in there must be 30 degrees. Very much a potential test question. So, hopefully these give you a little idea of what to expect on the test. I would ask that you get a little bit of homework done here as well to get a little extra practice. So on page 683, please do problems 3 through 21, and I'll see you tomorrow.